Hello friends, today we are discussing about the elimination reaction. What is elimination reaction? Elimination is a type of reaction that is used to transform a saturated compound into an unsaturated compound, which faces a double bond or a triple bond compound basically. And uh, and a removal of there is something group or a atom that is removed by a base or a nucleophile or a sometime metals basically. And the elimination part is a good living group or sometime a bad living group or a weak living group. And that will change the mechanism basically. And how it is changed, let's see in this video. First, we talk about the even reaction. Reaction, first even, is a unimolecular reaction and it involves the two steps. First is the ionization, the second one is the deprotonation. Let's see. First step. There is a ionization reaction. In this, carbocation as an intermediate is formed. Here we see that there is a carbocation that is formed here, basically, and that is the first step. In this reaction, we first step see that there is a formation of the carbocation take place. In the second step, there is a base or a metal. It can be a metal, okay? And let's take out this hydrogen from the substrate and a intermediate basically. And after that, there is a formation of the pi bond or a double bond take place, and the base will take out the this hydrogen. That part known as the deprotonation. Okay. Let's see some new things in this reaction. Let's see the features of the even reaction. In this reaction, we first see the formation of the carbon cation as an intermediate. Basically, it is a two-step reaction. In the first reaction, first step, the living group leaves and form a carbocation, and in the second step, a proton is removed by the base. So, first feature is also said that it is a two-step reaction. Okay, and in the second step, uh, the base is stronger, maybe a weaker, or sometimes in the first step, the living group can be a weaker or a stronger. It gives a different type of mechanisms. It is first we see that how the living group be a good in this reaction, and in the even reaction, we need a good living group, and the base is a mild base. In this, we need a poor living group or a good living, sorry, we need a good living group. And why we need a good living group? So that the carbocation is easily formed. And we need a mild base. It means that we need a low concentration of a nucleophile, low concentration of the nucleophile. Why we need a low concentration? So that it cannot be attack on the carbocation. We use the base to remove out the proton for the deprotonation. We does not wanted a attack of the nucleophile on the carbocation. So we take a low concentration of the nucleophile here. This is the first order kinematics reaction, and in this we see that it is a first order kinematics, and जो उसकी जो कंसंट्रेशन होती है किसी भी रेट ऑफ द रिएक्शन उसको हम लोग कुछ इस तरीके से लिखते हैं। इसमें जो आर एक्स होगा वो हैलाइड की कंसंट्रेशन पे डिपेंड करेगा डायरेक्टली। जो न्यूक्लियोफाइल की कंसंट्रेशन होगी उस पर ये कभी भी डिपेंड नहीं करेगा, यानी कि इसकी जो ऑर्डर होता है न्यूक्लियोफाइल का या बेस का, वो ऑर्डर क्या होता है, जीरो होता है। एंड द सबस्ट्रेट का जो ऑर्डर होता है यानी कि एल्काइल हैलाइड का, वो वन होता है। इसका क्या मतलब है, मैं आपको एक्सपेरिमेंटली बताता हूँ। इफ वी डबल द कंसंट्रेशन ऑफ द alkyl halide, then we see that it will also double the concentration of the alkyl halide. इसका मतलब वो रेट को दो गुना बढ़ा देगा। अगर हम इसको डबल करते हैं कंसंट्रेशन को, तो वो रेट ऑफ द रिएक्शन को भी डबल कर देगा। इसका मतलब ये क्या है, फर्स्ट ऑर्डर काइनेमेटिक्स को शो कर रहा है एक्सपेरिमेंटली। इट इज ऑर्डर ऑफ द रिएक्शन डिटरमाइन द एक्सपेरिमेंटली, नॉट theoretically. It is determined by the experiment. And on increasing the nucleophile concentration, on doubling the concentration of the nucleophile or a base as a water in soluble इसके लिए दिया हुआ है, नो इफेक्ट ऑन द रेट ऑफ द रिएक्शन, हम ऐसा पाते हैं कि इसमें कोई भी चेंज नहीं आता है। सो वी कैन से दैट जो इसका जो आर एक्स का जो ऑर्डर होगा वो वन होगा और न्यूक्लियोफाइल का जो ऑर्डर होगा वो जीरो होगा। तो ये फर्स्ट ऑर्डर काइनेमेटिक्स को शो करती है, ठीक है। लेट्स सी सम more features. Rate of the reaction is directly proportional for the formation of the carbocation. So in the 3-degree carbocation, that is more stable than the 2-degree carbocation than the 1-degree carbocation. So we conclude that for the rate of the reaction of the E2, sorry E1, E1 reaction की जो rate होगी वो fastest होगी for the 3 degree and the slowest होगी for the 1 degree halide. Let's talk about the energy profile diagram. Let's understand the energy profile diagram. In the first, we initially have the 3-degree halide or 2-degree halide. The leaving group will leave the first the substrate, and after that there is an intermediate form here, and that is intermediate for the lower peak for the minima, and the transition state will come first. In this transition state, we see that there is a breaking of the Br bond. Breaking of the Br bond will be take place in the TS1 state. And in the transition state 2, there is a proper orientation in which the proton is removed. It means the formation of the pi bond and the removal of proton is shown in the transition state 2. And finally, we get the alkene as unsaturated compound from the saturated compound. And there is a formation of the pi bond take place. That is the reaction coordinate here. That is the energy profile. And there is a removal of the beta hydrogen generally we study. And we see some examples now. See the most common example of the E1 reaction. That is the performed by the concentration H2SO4 as a dehydrating agent. Yes. And that is a 3-degree halide or alkyl halide. First, the carbocation will be formed like that, and after that, the protonation will be take place. मतलब जो प्रोटॉन होगा वो निकलेगा, deprotonation will be take place. So H जो SO4 था, इसने यहाँ से OH को निकाला था, वो क्या करेगा, इस प्रोटॉन को ले लेगा, and basically deprotonation will be take place ना, so that there will be a formation of the pi bond here like this, and यहाँ से HSO4 माइनस निकल जाएगा. This reaction happens like this. एंड जो हाइड्रोजन निकला है और OH जो था वो मिलके वाटर का फॉर्मेशन भी करेगा. Let's see some more examples. That is the most common example we see. The interesting examples will be come in picture when the stereochemistry include की जाएगी इसके अंदर. Let's make some correction here. Here we see that there is a HSO4 minus and the proton is removed by the HSO4 minus and it will form H2SO4 again because it not act as a catalyst. It is act as a catalyst because it moves the reaction forward. Without it, it can't happen. So the catalyst cannot be used in the reaction actually. So we finally get the catalyst back. How HSO4 minus come? I told you. HSO4 convert into a HSO4 minus and the H plus will take